the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Okay, good evening, and I guess we should do it like this. So, good evening, I guess you should be able to hear me. Maybe now even better. So, welcome back, I guess, to the second part of trying to solve KrzaQ's WCTF challenge, TPM2137, which I failed to fully solve last week, but we will try to solve it now. Try to. That's the keyword here. You will see me struggle a lot with trying to finish this challenge, because I've basically spent like 1 hour trying to, maybe a little more than 1 hour, trying to figure out what's the difference between my old code which worked and my new code which doesn't work, and I have no idea. I mean, I found a couple of different differences, but well, some of them even made sense, but that doesn't seem to affect anything, so yeah. Thankfully, I have a plan B, so worst case scenario, we will go with a different solution than the one I did, which should be fine as well, a little bit manual, maybe more manual. And if we go for that one, then I will show you the original intention anyway later on. So, that's it. Today's moderator yeah, today's moderator is KrzaQ. His name is here. And if you have any questions on YouTube chat, IRC, or Discord, then you have to ping KrzaQ. Again, his nickname is here. You know, on Discord, on YouTube chat, you have to use the @ and then type the nickname. And on IRC, you don't have to do that. But yeah, if you don't ping KrzaQ, then I might not notice the question. I am looking sometimes on the chat, but KrzaQ is looking all the time at the chat, and he's copying the questions to our secret telepathic website that stores the questions for me. And yeah, if you're on IRC, you can also use !Q. I think that works also on Discord, but it doesn't copy your nickname to the panel, so there's that too. And I guess, yeah, let's do the standard stuff, and then like in around 10 minutes we can start the actual topic. I'm going to move the camera a little bit more after all. Okay, perfect. The usual stuff in that case. Usual stuff. Wait, we need to start with this one. And oh wow, my drivers of my keyboard do not work. We have to fix it before we start streaming. I'm sorry for that, that was unexpected. Thankfully I do have a script for that. Yeah, my keyboard did reboot yesterday for some reason while I was playing. Of course, when I was playing, like middle of the action, and then my keyboard freezes and I can move with the mouse, but I cannot move around. Yeah, but I didn't die yesterday in the game. That's good. Perfect. Now it should work. Yes, it works. Perfect. So this is KrzaQ's website. And yeah, visit it. There is some old archival content there, which is pretty interesting. And again, thank you, KrzaQ, for being here and moderating today. Now, about Paged Out, which is the new experimental one-page, one-article free magazine, it will come out next week, as in the first issue should be out next week, unless we have problems of some kind. But if we don't, then it should be out next week. We have already, as you can see, over 50 articles. We have 54 articles. Some of them are still being in review. 9 of them are still in review, but that should soon end. So yeah, if you still want to send in an article for the first issue, you basically had to do it yesterday or maybe today. If you still do it today and we get it reviewed by Saturday morning, it should still be fine. But yeah, that's kind of like stretching it already. That being said, there is also this new website, well, sub-website, like web page basically, about ads in Paged Out. There will be two kinds of ads. There will be community ads, which will be free to make, as in like you do not pay for an advertisement in Paged Out, you just send us the ad and we print it. And this is only for free projects, free tutorials, free websites, free tools, whatever. Like basically, if you have a community project which is beneficial for our IT community, then you can advertise it for free in Paged Out. But it does have to be free. It doesn't have to be open, but it does have to be free. There must be no strings attached. It cannot be like, yeah, this is like a limited version is free, but you actually have to pay for a a full featured version. None of that stuff for community ads, only free stuff. If you are making cool free things, for example, posting tutorials on your blog, then you can send in an ad. And if your company is interested in buying a sponsorship ad too, because I don't know, you think that Paged Out is cool or something like that, we also have space for that. But I guess, like, as you can see here, since we don't really expect any interest in sponsorship ads for issue 1, this section will be rather light on details. So basically you have to contact me anyway if you want to buy an ad. We have space for around 10 community ads in the... Might be less, but I would say around 10 for the first issue. And I think we received already 2 or 3 ads, yeah, 3 community ads so far. And I think 5 other projects also asked us about how to send in a community ad. So there's that. So there are still a couple of more places probably. And yeah, if more ads come, then we will have to choose which one we publish actually. First come, first served basically for the first issue, then we'll have to do it in a different way. I wanted to let you know about that because the deadline for the community ads is this Saturday. Yeah, like we'll basically select as many ads as we can fit into, like, while still maintaining this thing here. We'll fit as many community ads and sponsorship ads as we can, but the cutoff date will be on Saturday. So there's that. Now, do I have anything on Twitter? Yeah, well, basically just what I just said right now. So yeah, I don't think we have to repeat it. One last thing is this hackathon thingy, which is happening in September in Poland. Is going to be the biggest hackathon in Europe, like a programming hackathon, but there will be also security events there. A couple of, I think like 2,000 people or something participated last year. So if you're interested in hackathons, totally check it out. The website is hackia.pl. Cool. So I guess we can. I'm going to look at the questions and then we can get back to the challenge at hand, which is this challenge, WCTF TPM. If you did not watch last week's live stream, do not worry. I will quickly explain what did we do last week, and so we can continue this week. It will be a good reminder for me as well. Okay, questions. You should see the questions here in this bar in a second. Here we go. Okay, I made a GUI C program with GTK. There is an input area and a button to submit. When clicked, the input button is copied into a character array using string copy. How to exploit it? You have to basically watch buffer overflow tutorials or read about buffer overflow, because this is what you want to do. You want to probably to do a buffer overflow where you have a null byte at the end. I would also suggest actually disabling any kind of protections on your application, because if you don't do that, you will have a really hard time learning. So disable ASLR, disable stack cookies, and maybe even disable executable stack so that it kinda works for you better at the beginning. And I guess that's about it. In the end, it will come down to properly formatting an input and putting it in the field. You might have some more problems because if it's GTK, if it's an input field, it probably requires Unicode. So if you didn't do ever any buffer overflows, like any exploitation of buffer overflows, then I would actually suggest not doing it this way, because you will struggle with Unicode or whatever character encoding does GTK in this case use. And it will be rather harder to exploit than it normally is. So yeah, try like with a text program maybe. Otherwise, yeah, it's like boils down to understanding how a buffer overflow works, and then the usual, like override the return address, and if you have stack protections and so on disabled, and cookies disabled, and ASLR disabled, you can just jump to your shellcode in the buffer, and that's it. Do you remember your first CTF? How did it go? My first CTF, okay, that's a good question. So before I participated in a CTF, I participated in war games, and I think on my first war game, it was actually like really similar to a CTF, because currently war games is like a website, but that was more like a tournament, more like a CTF, and we were disqualified because we played with a friend. That was like 2004-ish, maybe 2003-ish. And we found a way to exploit all the challenges in an unintended way, and the organizers did not appreciate it. So yeah, so there's that. Yeah, basically it was like you had shell access, and you had an executable which had a suit bit from a different user, and if you exploited that executable, you got access to the shell account of a different user. And there were like levels of like how deep you can go. I don't know if there were like 10 levels or 8 levels, something like that. And what we did, it turned out that due to some weird settings, we can do an LD preload with our library on that, on any executable, even though it was SUID, which is, again, 2004 stuff, right? Even then, like, that shouldn't happen, but that was some misconfiguration. But yeah, and we just like jumped through all users and went to the end. So yeah, they didn't like that at all. And later, I guess later we played, like even before, like years before we established Dragon Sector, we played on Confidence. That's one of the Polish security conferences. We played with first my company, it was Hispasec at the time, you know, the folks from behind Virus Total before Google bought it. We played a CTF on Confidence and we did win it. But there were also, and before there were, I played a couple of individual CTFs. I usually qualified in the qualification round with just internet, and then on the offline finals, which are individual, I got second place the first time because I had no idea what's the intention behind the task. They were pretty atypical. And for the for the 2 second times on that individual CTFs, or like 3 times, I've always won it. So yeah, that's my experience with CTFs before even we created Dragon Sector. I had some history of winning CTFs already. I know that's not the answer you might expect, because usually it's like, yeah, I had no idea about CTFs and I failed miserably. But for me, it was, I had like 15 years of programming experience already, and some security experience, mostly with war game sites. So first CTFs were easier than normally, I would say. Paged Out will be a monthly. No, Paged Out will be, I guess the idea is to publish it every quarter. I'm not saying that's the beginning of a quarter or end of a quarter, but to have one per quarter. That might not work. It might be 3 or 2 issues per year, depending on how many folks want to write articles, basically. Like once we have 50 or more articles, we will finalize the issue and publish it. That's the idea. So not monthly, but quarterly. What is your suggestion for beginners? Beginners in what? I guess I need to write it down, like my suggestions for beginners for CTFs, for example, because that is a question which comes up quite a lot. Again, my typical suggestion is find a team and play with a team, because the more the merrier, and it's, you know, you learn from each other and you motivate each other. That's really good. Then read a lot of write-ups. You don't have to understand anything from the write-ups, just read a lot of write-ups, because that puts in your head a lot of knowledge about what is possible and where to find that thing. And next time you'll see a CTF, you find a problem, you think like, oh, on that write-up, I actually saw it, so let's read that write-up. It might not be the solution, usually isn't the solution to the task you are trying to solve, but it will be pretty, you will at least know how to start, and that's the important thing here. And apart from that, experience, and you do have to be really good at programming. You do not have to be, you know, like an algorithmical whiz or anything like that, but you do have to write really quickly simple scripts for CTFs. That's the norm, basically. Do we need good programming skills to do security stuff? Yes and no. It's like this, and this is my opinion only. Until a certain level, which is around, I would say, like intermediate-ish, you do not need to know programming. If you want to get to advanced or expert level, you need to know programming. That isn't true for all security areas, because security is pretty wide. If you do, I don't know, like, I cannot think of a good example now, but because, you know, there's like network security, for example, there's blue teaming, there's red teaming, there's vulnerability research, bug bounties, there's mobile security, forensics, and so on. So your mileage may vary in each of these different types of security specializations. But in the end, like even for example in forensics, there is a point where you know all the tools, you can use the tools, but the tools get you only this far. And if you want to like breach that boundary, you need to be able to write your own tools, and to do that, you need programming. That's how it works, basically. And that's my opinion. Like I expect that some people might disagree. And also, like if you're going for example, for security management of companies and like managing security teams, you might need more management expertise than actual programming expertise, for example. But you do need to know something at least. By exploiting a GUI program, I mean how do I interact with a GUI program using Python? That depends a lot on the operating system and so on. You'd have to basically, if you're thinking about GTK, it would boil down to on Linux. I'm assuming it's GTK on Linux. You'd have to figure out how to do with Python, for example, keystroke injection. Because what you need to do is you need to select the window and you need to emulate typing in the exploit. If you have the field, right, you need to select that field, put your cursor focus on it, and then basically keystroke the exploit in. And that's basically it if you have a GUI program. Please note that exploiting GUI programs is very atypical. You do not do that often because GUI programs are usually running with your own privileges anyway, so there is no security boundary to cross, and which means there is no reason to exploit it unless doing a training or something like that. There might be cases where you want to do that, but that's pretty atypical. So yeah. But what you want to do is you want a way to interact, to emulate basically user interaction with the application. So look at the X11 protocol in Python, how to use X11, like how to emulate mouse movement or actually send messages to a given window, telling that window that the mouse has moved, that the keyboard has moved. That's one thing on Windows that would be do the same with Windows API. The problem here is with GTK, because if that would be Windows API and like a window created with Windows API, then there would be a programmatical way, really easy way to pinpoint the exact location of that input box. Instead of moving the mouse, you could just send the message like with the input to the input box, and that might be way easier, but you cannot do that with GTK, as far as I know. Will you do some modern exploitations such as ASLR bypass? Did we do any ASLR bypass? We might do it someday on the stream, why not? Yeah, ASLR bypass isn't... yeah, there are methods to do it which are basically a bypass, which make you don't care about ASLR due to various reasons, usually because you can leak memory. Are you going to organize Summer Game Dev Challenge this year? Yes. As soon as Paged Out is out, then I will move to organizing it. Is the management path for cybersecurity? Not necessarily, no. It can be one of the paths, yes, but not necessarily. Like, risk management is more like a... It depends on how you look at it. You might look at it as a business decision as well. Like, it's more... People who are not into security might do risk assessment and say that, yeah, like, there is risk here, but the dollar value of this isn't really something to worry about, so we can ignore it. But that is how I usually view risk assessment. I'm more into, you know, like strict technical security. Something is exploitable or isn't exploitable. That's mostly what I care about. But then there are people needed who make these business decisions as well. So that might be one path. Another path is, you know, and even in security teams, you need to have usually a manager who handles like shelters the team from other stuff, from paperwork, and like makes sure that the team is running smoothly, and also if the person has enough technical skills, like tries to guide the team. But usually if you have great people, then they guide themselves. If we send enough questions, will the stream turn into Q&A? That's an excellent question. No, because I will do 2 more questions and then I will move to the main topic. Nowadays, exploiting GUI programs has become more common because of things like Mac adding GUI-only security boundaries for various settings. Usually you have to emulate mouse plus keyboard. Okay, thank you. I didn't know that because I don't do any Mac. Last time I done Mac security was in 2009-ish. And yeah, so that might be true in the Mac world. It might be true in some cases in the Windows world as well, but that's not, again, not a typical thing. What type of malware samples do you recommend for beginners in order to start malware analysis? Well, that's a good question, actually. I don't think I can give you any answer, though, because, well, so it's like this. If you know already reverse engineering, like you have good skills with reverse engineering, then it doesn't really matter. Like pick whatever which isn't super complicated and that can work for you. Sorry. And on the other hand, if you do not know reverse engineering, then start with learning reverse engineering and then jump to malware. Yeah, but I cannot name any viruses or malware that I would recommend you reverse engineering, mostly because I didn't do any malware analysis for the last, again, from 2009-ish, so yeah, so I'm out of date. This is a question which you might want to ask, for example, Hasharazadeh on Twitter. She might be able to give you a better answer than I can. Lately, Project Zero disclosed 5 iOS vulnerabilities. Can you stream about it once more information get released? Not really, because I'm not doing any iOS or Mac stuff. I'm totally detached from like iOS or Mac world, so yeah, so I do not have any idea about it, and I do not have any hardware or environment for it, so yeah, sorry. Yeah, but maybe I should do it. I'm pretty sure that would get quite a lot of views. But yeah, today is Verilog instead, I'm sorry. Back in the days, iOS was the name of Cisco operating system, which was running on network hardware, by the way, and yeah, and then Apple came with another iOS, so yeah, just a random trivia, but you didn't really want to know. Cool. If there will be any more questions, I will get back to them in a break, or when I finish the task. And yeah, so let's talk about the task. Again, the task is downloadable on KrzaQ's Twitter. I will give you the links to KrzaQ's Twitter on the chats right now. Long story short, if we go here, it's basically this device, like a TPM device. Wait, this is the spoiler solution, which I did not want to look. I wanted to look at description. Yeah, here we go. Yeah, this is this like device which basically has an input, which is UART, which is a serial protocol, and it has 2 LEDs, which are, well, negative, which means that they go low if they are active. And the idea is that you send using UART 8 characters, and exactly 8 characters, and after sending 8 characters, one of these LEDs would go low, which means it would lit up. For example, the green one for OK would light up, or the red one for wrong will light up. And what we did last time is, oh, and what you get, by the way, is a Verilog stream, which we then decompiled, I guess, to Verilog using some tools. That was last stream. And then we started looking at it. And then we decided to write a test bench around it. So basically what we've written is we've written another piece of code which interacted with the device using the UART protocol, and it also sent the clock in, and it also provided the, like, let's say, fake emulated LEDs. And we emulated this device, well, having the Verilog of this device, we emulated it using Verilator, which converted the Verilog code, which is this device, into C++ classes, which we could use, like, for emulation. And yeah, and we were able to run it. And what we figured out, we basically generated a really large, something like this, where each of these lines, each of the vertical lines here, like each of them, right, is one internal state of a register of the Verilog machine. It's basically wires and registers. Registers connected with wires and a lot of logical gates, you know, the typical AND gates, OR gates, NAND gates, NOR gates, XOR gates, and so on and so forth. And yeah, like the math is being done and is being stored in the registers. So every clock cycle, we put either 1 or 0 in each register's column. So each register has a column, and a bright dot, a white dot is a 1, and a black dot is a 0. And these here are kind of special because they were related to the UART communication. And what we we started looking at this and analyzing this to figure out what is happening when we are sending 8 characters using UART. And what we end up with is basically a mapping between which register we store which bit of the characters we send. So we send 64 bits, 8 characters, 64 bits, and in which register is it sent. And then what we wanted to do is we wanted to completely detach the serial sending to the device, which, by the way, this is like the last cycle when the sending is done. And we wanted to just from here be able to put proper in the registers themselves, put bits, and then see did it work or did it not work. So this is where we got last time. We got rid of all the serial communication and we are able to put directly the bits into the registers of the device. We do not care about serial communication anymore. Everything is paralleled for us. We set the registers, we run it for 1 clock cycle, and that's it. Now, what I aimed to do last time is basically to generate an equation out of these registers, because if you think about it, is like this. You have 64 registers, 64 1-bit registers, where you put the characters, right, of the password which you send. The password or the flag, this is the flag basically, right? And there are 64 of them. And then there are the 2 LEDs, 2 light emitting diodes. One is a green one, which is being lit if everything is fine, and the other one is red one. And there are like specific pins, registers, or wires, whatever, probably wires, which will be changed to 0, to false, to light up a given LED. And what we are interested in, of course, is this green LED to light up, to go like this wire which is connected here. We want it to go low, to false, because on this other side the LED is connected to like a VCC, which is, you know, like a plus, I don't know, like 3 volts or whatever. There's some resistor, and so we want it to go low because that means that the what's it called, like energy is flowing through LED and is being lit. So that's what we want to achieve. Now, what is in between? That's the question. What is in between these registers and this LED? And it's, I guess, pretty simple to figure out. There are some gates, like some logic gates. There might be like NAND gates and so on. So like there is some stuff being here, like between these two. There might be, I don't know, for all I know is like, for example, an OR gate. So this is an OR gate, and then it goes to, and like each like couple of registers are being connected like this using some gates, right? I'm not going to obviously draw all the gates. Yeah, this is another OR gate. I apologize for my terrible drawing. And in the end, they will be somehow they will, like, you know, boil down to just two registers, which one will be 2 wires, or basically one and a half wire. One wire will be directly connected, for example, to the good LED, and the other wire will be connected with an NOT gate to the other LED, right? So if it's true, then like if we get true here, then this will go low and this will go high. So this will this will be turned on. I'm sorry, this will be shine brightly. And on the other hand, this will go high and this will go low, and this will be turned on, and this is what we want. So this is basically what we have, and we have this written in Verilog, which looks not really nice. And what I wanted to do is I wanted to automatically generate an equation from like, these are the inputs, our unknowns in the equation, and this is the output. We want all these inputs connected with all these gates. We want them to be at the end equal to 0 or actually like just this wire. We want this wire at the end to be equal to 0. And we want this equation to be automatically generated. That was the idea, and we failed. Because yeah, we did get the equation generated, but it turned out that the equation part is actually missing. And that was not the case when I originally solved it, and when I originally solved it, the equation part was there. And yeah, and I tried to, and this is where I got stuck last time, and I couldn't figure it out, and I decided to just call it a day, and because we were already 2 hours in, and just finish it. Yeah, and then I spent 1 hour on it, trying to figure out what is the difference between my previous solution and my solution right now. I still have no idea. I found a couple of differences, they didn't matter. So we are going to do it in a different way. We are still probably going to do the equation, but we are not going to use tools to create the equation. We are going to do it manually. And by doing manually, we might find the mistake which I made. The mistake is like this. When I read through the logs of Yoss's SMT, which is the tool which I used to generate the equation from Verilog to SMT, basically. SMT form, by the way, says like this. Again, if you weren't here with us last time, this is the Verilog code which we have. Let's make it a little bit bigger. These are just definitions, so let's, yeah, this is the Verilog code which we have, and what we wanted to generate is the SMT form of an equation. I know it doesn't look like very readable, but it doesn't have to be, because there are tools to solve such equations. For example, Z3. We can just use Z3 to solve this equation, and we would be done with it. But the problem is that there are a lot of definitions here of ports, but there is the actual equation part is missing. And as you can see, the state for our pin 37, pin 37 is somewhere written here. Where is it written? Maybe it's written in the other part of the description. Here we go. Yeah. Yeah. Pin 37 is set to true. It's just set to true. Like in the equation, it's set to true, meaning it's high, it's not shining, which means that the thing which generated the equation, it took the Verilog, it optimized it, and it turned out that during optimization, LED 37 is always is going to be set to true regardless of the input state. There is no solution to this. This is what it's telling us. It optimized out everything because, yeah, why is that? Because probably there is one point in the whole equation which makes the equation unsolvable, or rather makes this equation, because the equation is equals to false, and yeah, makes this equation unsolvable, and therefore it's always equal to true. Therefore, yeah, we have this, and we do not have any actual logic equation generated because that's optimized out. So that's the problem. And I have no idea why is that, but I hope we will reach the idea why is that. And yeah, and to do that, we will actually start to read this Verilog code in more detail than we would like. I'm sorry. That is what's going to happen today. So what I'm going to do is I'm going to try to figure out how is the inputs, how are the inputs connected to the LEDs we have at the end. We know the LED is pin 35-ish, 37-ish. I shouldn't have called, yeah, 37. Pin 35 by base clock. I guess we could just like, let's do Control H, CO clock, yeah. So yeah, this is a wire, and we can see that actually to this wire is just this register is assigned. So, well, we don't know if it's a register or a wire. A register has a value, a wire is just like something which connects to things. Like an actual wire. You can really imagine an actual wire. Okay. And it seems it's just related to pin 11, where pin 11 is set to... Okay, that's pretty weird. Why is it set to a pin and not to any of these? Do we even have a pin 11? We have a pin 11, and pin 11, what is pin 11? Is red. Okay. That's pretty weird already. No, that's actually fine. Because it's as I said, like one LED is being turned on when the other isn't, so it can be a negation of that, the state of the other LED, and the state of the other LED, the state of the negative LED, of the red LED is being set with this wire or register. It's a wire, and it's being set due to this equation. And let's look at it. This is, by the way, a typical short if notation. So yeah, you know, if it's like, it's basically if you have A equals, no. If A, then B equals, I don't know, C, else B equals D. Then you can write the same thing, the identical thing, using B equals A, C, or D. Yeah, this is the same thing, same notation. It's popular in a couple of languages like C. I think it's also in PHP and also in, I'm not sure if it's in JavaScript though, but whatever. It's definitely here, definitely in system Verilog or Verilog, which I think we're looking at Verilog, so it's there. Cool, so let's go to the bottom of this. If this is, oh, by the way, each of these, regardless if it's a wire or a register, can have, it's a boolean, right? It's a bool value. It has either true or false, 0 or 1, or 1 and 0 actually. So if N204 is 0, let's assume it's 0, then we don't look here, we look here, then it's a 0. Now the question is, do we want it to be 0 or do we want it to be 1 in the end, right? So actually I'm going to go back to the other thing. Was it this one? Let's see what was this one. Yeah. So pin 11 is this. So if it's 0, then the other one is 1. So we need this one to be 1. Therefore the other one will be 0. The green one will be 0. Okay. So yeah, so we need this to be 1. Therefore, if we need it to be 1, then we cannot allow it to be 1. Sorry, to be 0. We have it has to be 1. So this has to be 1, this has to be 1, this has to be 1, and this has to be 1. Otherwise, if one of them isn't 1, which one of them is 0, then we fall into one of these here, or this just gets the 0 directly assigned to this pin. So yeah, I guess like another way to write it is, sorry, what was N342 is equal to N204. Oh, I cannot write, and yeah, I'm going to do like this. And N157 and 183 and 148. This is basically what this line says, that all of these need to be 1, otherwise it's 0. Okay, let's look how this is like one of them. It doesn't matter which one, we are just doing a reconnaissance, we're just trying to figure out what is this, where is it assigned to. It's a wire, and it's being assigned here to this other wire or register. I don't know if it's a wire or if it's a register. It's probably a wire. And it's being assigned here. And here we also have the same pattern. It's an identical pattern. All of these need to be 1. So yeah, this is basically where the tree collapses. The phase where you have already like intermediate results and you just need to collapse them into the final result. So this is this. I'm just going for a random one. I'm trying to see how far are we from the top. Okay, and this is another one, same pattern. Let's go up. We are going up the tree right now. And yeah, we already reached input. So okay, so we know that we have like the input, then there is one level of collapse, second level of collapse, and at the third level of collapse we have the actual pins of the LEDs, of a red LED and a green LED next to it, and there are the inputs here. So yeah, what we have to do is we basically have to figure out what are the actual needed values in these inputs. Like for example, 209, does it have to have a 1 or does it have to have a 0? I don't know. So we will have to somehow figure that out. Let's look again at this equation here. And yeah, this is again a pretty typical scenario. Let's take a look at if N194 is also an input. It's also an input, so all of these are inputs basically. So yeah, what we can do is we can basically, or rather what we have to do, is we have to grab all of these things and put them in one place, because there is quite a lot of different other code here, which was, for example, responsible for UART because we didn't cut it out, and it's polluting our view. We cannot see it because there is too much stuff here. So what we want to do in the end, we want to just grab the lines which are directly responsible for the state of the LEDs at the end, and it will be way shorter than the current this many lines. You can ignore this, I added it while testing and it doesn't do anything. And we basically already can tell that we didn't see any always at positive edge clock, which means we know that the input isn't really clocked. We do not have to progress a clock to do some setting of to allow settings of some registers. It's just a couple of wires with gates in between connected by a series of gates. And in our case, it was so far the AND gates, but I want to check like some other random inputs. Here it looks like the same thing. Here, yeah, here it's a little bit more complicated, because you see that there's a negation here, for example. There is, yeah, this is like reverse, right? Usually you had the 0 after the the colon, and here you had the rest of the equation, but it's the other way around. So we know that there are some gates here, some OR gates, well actually there are no gates. It seems like it's directly taking the inputs and doing NOTs of the inputs. And yeah, so the plan right now is to extract everything, then turn it into some more decent form of an equation, and having that equation, put it in Z3, or like whatever, like make the equation by hand, basically. And by hand, I do mean by a Python script, I do not mean by hand, obviously. And yeah, what I think is that somewhere in the equation we will find something which short circuits it. But the result is always not the one we want it to be. It's always 0, for example. Cool, but we need to find it. I'm going to call it like manual.py, because it's going to be semi-manual, the script. And first what I'm going to do, it's going to be really ugly text parsing, I'm going to basically say, because I don't want to do a lot of parsing, but we need to do some parsing, I guess. Now, what we need to do is we need to read it to some form of an array. Okay, opening the file. Then read it into lines. F read split lines. As I mentioned, every time I prefer this to read lines because it removes the end of the line character. And now we need to denote the inputs. To do it automatically, we need an array of inputs, and that's between 2 and 65. So our inputs are between lines 2 and 65, so 66, because 65 doesn't count anymore. I guess we are going to use some regular expressions, so let's grab RE. And for each of them, what we need to do is I'm not going to use regular expression for this, though. I'm just going to do, or I can use whatever, doesn't matter. We can use input. I cannot write. Then we are interested in n, then there is like a number, and the number is rather long, and we don't care about anything else. We know that there might be either comma here or an end of line, but that doesn't really matter for us. We just want to grab the number. So how do you do that? Find all, I think that would be group 1 for x for x in lines. Okay, and let's see what we get. We get an error because I totally cannot regex in Python, but that's fine. Yeah, what problem are we what problem are we trying to solve? We're trying to convert manually a simple Verilog code which looks like this into an equation which we can then put in a stat solver basically to get a flag. Okay, and what I'm writing right now is the script which converts it. Yeah, list object doesn't have group. Perfect. Can you tell me? Oh, that's perfect. You can just do this. Index out of range because after 81 it didn't find what it needed to find. Why didn't it find 81 is here? Where's another one? 66. Oh wait. That's because yeah, sorry. This is like a typical mistake. This is 1 indexed and we are using 0 indexed. So this is 5. This is 1. Yeah. Okay, 49 here. Then 81 here, and our code says 49 here, 81 here, everything is fine. So we got the inputs. And now we need to parse through all the other lines, whereby all the other lines, by the way, is any register initialized to a 1? No, all of them are 0. Okay, that's fine. No, there are some ones. Huh, that's interesting. No, it's an assign, not a register. Okay, perfect. So, now what we need to do is we need to parse from this line, which is again 1 less, up to the end of a file. And we want to, first of all, let's just print out, oh, we need a set out of this, by the way, yeah. So, for line in lines between 500 this up to the end of a file, what we want is, if it's not assigned, then assign not in line, then we do not care about the line. Maybe it's not a set, maybe it's a list. And then what we want to do is basically check if any of these registers is here. Now the funny thing is that what I'm worried about is that, for example, here, right, if we have n18, that would match if I just do a stupid string match, and that would just match it, which isn't helpful and is not going to be helpful in our case. So I'm wondering if I can do anything about it. But I don't think I can actually without trying to parse it in some way. Well, okay, so let's do it like this. I'm going to use this, and I'm going in a given line. So, let's do it like this. I'm going to print in a line, find all, and I'm going to find all the registers because this is greedy, which means it will go until it matches in line. And let's see what this gives me. Okay, that's pretty nice actually. So we know that the first one is always the assign. Okay, that's perfect. And now what we need to do is we need to find, so this is the regs used, and for I in inputs, if found equals for, no, that's fine. If I in inputs, then if I in regs used, then that's we can do a break. Otherwise, like else with a for, we do a continue. And we can print it. Okay. Okay. That is pretty nice. Yeah, that's not bad. It might even be working actually. Like let's do a manual check here. N170. Is it an input? It might not be an input, but it is an input. Oh, by the way, if we want to be sure that we have inputs only on the right side and not on the left side, on the left side there should be no inputs anyway, so that doesn't matter. Ignore me. Okay. So this is fine, and this is just the first... Okay, what's this? Because I didn't see this when we are going up the tree. Which one of these do we have? Like an 11, 17, and 29. I'm not printing them anymore. We don't have an input 11. We have only 111. That's weird. Why did this match? No, see an input 29 either. So there's a mistake in our code, in my code. But on the other hand, now that I'm thinking about it, we might not want to do that at all, because we'll have to make a dependency tree probably. I'm going to just take a look. Line 17, one more tab. No, this is how it should be. It's like this. If for runs out of inputs, then this line is executed. If for doesn't run out of inputs but breaks, then this line is not executed. Yeah, for else. That's a thing in Python. It might work the other way around though, so I'm going to check. For I in x range 1, well maybe 2, print I, and then we're going to not do a break, I'm going to do else, print ASDF. Yeah, that's fine. And now if I do this, print I, and then do a break, else print ASDF, and ASDF is not there, because I exited for with a break. So that's fine. I'm basically trying to find an input which is in this list, and if I do, then I break. And if I break, then I print. I jump here, right? If I break, I jump here. If I don't break, which means I did not find any input in the registers used, then I continue. So you know what I can do here is I can basically print I at the beginning. Let's do this, because I still have it in, well, you know, variables in Python aren't block scoped, they are function scoped, so we can totally use this. Okay, so I said that this isn't good, this is incorrect. And it says that it found N17. Well, there is N17 here, but there is no N17 in inputs. Is there N17 in inputs? There is an N17 in inputs. No, there's not N17 in inputs. Oh, that's the problem. Oh, okay, now I get it. I think the problem is like this, that if I have N1, 2, 3, 4, this find all actually says N1, N1, 2, and N1, 2, 3, 4. We are going to check it. Yeah, what we want is N, then 9 plus, okay, and then N1, 2, 3, 4, and let's see what this returns. No, that's fine. I don't get it. Python, what are you doing to me? Okay, so is N17 even here? Yeah, we have it. 217. 17, and there's... Oh, don't tell me. Yeah. I'm stupid, I'm sorry. 0 to 9, obviously. It's so typical that the mistakes are usually of that kind. Okay, now it's better, but I did remove this. Okay, now it's way better. I think it's way better. Hopefully it's way better. So we should have... each of these lines seems to take 4 inputs. We have 64 inputs. That means we should have 16 of these lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Yeah, so we have all of them. Now, I guess there are a lot of stuff also going here, but before we go any further, what I would love to do is I would love to convert all of these lines into something more looking like Python. And this isn't looking like Python. Yeah, that's true. Like, if you're trying to solve a problem with regular expressions, now you have 2 problems. That's so true. Cool. So how do we go about it? Can we do... Python doesn't have the syntax, right? It would be nice if Python would have the syntax. Python has a reverse syntax though, I think. No, Python doesn't have a syntax. That would help so much. Because I could just, you know, compile it and then do something with it. In Python, what you can do, by the way, is you can do a equals 1 if something else something else. Yeah. And that would mean that a is going to be equal 1 if this condition is true, or otherwise a is going to be equal to 5. Which you can do in Python, but you cannot do the standard 3-operand notation thingy. So how do we do it without writing a full-time parser? Because I do not want to write a proper parser for it. I want to cheat this whole thing. I guess we can do a couple of things. We can start with, so let's do like this. Let's create a function which is going to take a string. So a string to some more like Python. Let's call it a Python, because if we convert it to Python notation, then we can directly use Z3, because Z3 has all the Python operands overloaded and we can just use it. Okay, so we take a line, or a string actually, and then we output the Python code, like we return another string, which is Python code. What we want to do here is we want to start with getting rid of this, because this isn't helping. We want to split it by this as well. So, okay. So in this case, in each case, what we want to do is we want to do this. Return like py, for example. Let's call it py. And py for now is going to just be an empty string, but that's fine, and we'll be printing a lot of stuff. So first of all, what we want is we want to split s by this. And now we have like 2 sides, the assigned side and the not assigned side. So the left side, like left, is the left and right. And I'm pretty certain we'll have only one of them, so let's see if it works, if I don't have to actually cast it to something. No, but it works. That's fine, yeah. So I get this. Now I want to actually remove this, because this is not helping me in any way. So what can I do to make it easy? Yeah, don't look. This is ugly, don't look. I hope you're not looking. By the way, is any on the left side? Do we get any comments on the left side? We do not get any comment on the left side. The comments are only on the right side. That's good. So what we do is we're going to... You're not watching, that's good. Split it by this. And we take 0 and we append it to split by this, and we take this one. Okay. Now what this is going to do is it's basically going to grab this part, and it's going to grab this part, and it's going to concatenate them, and it's going to ignore anything in the middle. And we can actually do it even before we do the splits. We can do it here, so it affects everything. If we have two comments, it fails, obviously, but that's fine, because we do not have two comments. This is pretty specific code. And yeah, now it works marvelously. We can even trim it if we like. Do we like to trim it? We always like to trim it. Okay, trim. Is it trim or it's strip in Python? It's strip. I don't remember. Trim. Yeah, because languages either have a strip or a trim function. I always confuse which language is which. Anyway, that's fine. It isn't fine. Why isn't it? Why is it doing this space here? We can remove a comma, by the way, as well. So, not comma, but a semicolon. And replace it with an empty string. Okay. Oh, yeah. Now it makes more sense. Perfect. Cool. So in this case, it's super easy to do a Python notation. We can do one immediately. Oh, we also want for the left side, we want to remove the assign. So replace the assign with nothing. Perfect. Okay, that's fine. So this is super easy. We just write like print left then equals then right, or rather left right. Can even do this py equals. Okay. Yeah, and this is proper Python notation. This isn't. So, oh, what else I can change is I can change this already. So replace this thingy, or rather, I'm just going to remove this thing from here. No, maybe no. I'll just go with true and false, or 0 and 1. 0 and 1 is fine. So yeah, let's do it like this. 0 and 1. Again, if you do not know Verilog, this means that the size of this constant is 1 bit, and the notation is bits. So this is binary, like a binary notation, right? It could be 1'D and then like a decimal, which doesn't make sense for 1 bit, but you can have like 10 bits, for example, hexadecimal, and then like a hexadecimal value here, which fits into 10 bits, obviously. Cool, so this is, yeah, this is starting to look more like Python. Now we can change easily this into not in Python, or like not rather, or like not negate, I don't know. What is Z3? Do I have Z3 here? Yeah, that's totally not how you import Z3. If I do a bit vector x of the size 1, so A is, yeah, and I want to, so B is going to be, can I do not A? No, I cannot do not A. Can I do negation A? Yeah, I can. This is, by the way, how we are going to do it in the end. We are going to use Z3. This is declaring a variable called x, which an unknown in an equation, that kind of variable. And this is the size in bits, a bit vector of the size 1, which means 1 bit. And then we're going to basically write a, like normal Python language, we're going to write the expression. And as you can see, if we type out B, we get an equation that we've written so far. So this is like the equation so far is not x. And this is what we are aiming at. Because then we can like, we can easily solve it. We can create a solver, and we can tell the solver that we want b to be equal to 1, and now we will tell it to like try to solve the equation, and it says sat, which means the equation is satisfied, the equation has been solved, and we can do the model, and it will tell us that the equation can be solved for x equals 0, because if x is equals 0, which means we have 0 here, then it's negated, it's 1, and so we get 1. So this is what we are aiming at. We're going to do that, but before we do that, we need to have like a Python-like equation. Cool. Yeah, let's run it again, and now we need to again try to figure out how to convert this into Python notation without exerting ourselves. And in all honesty, I'm starting to think about actually doing it the proper way. Yeah, I think it will. Yeah, we might have to do it the proper way. So the proper way is going to be like this. We are going to do a recursive function which, when finding a bracket, goes into recursion basically. And then what it does is going to do a split by the question mark without brackets, and a split by a colon, by question mark and colon, so we get 3 operands. And then if an operand has brackets, then we do something. If the operand doesn't have brackets, then we do something else. Yeah, and because having this, we will be able to do having this notation like one single thing, we will be able to convert it to because it's never 2 registers, it's always a constant on a register, so we'll be able to say that this value is supposed to be actually no, you know what, we do not have to do an equation. Now it came to me, we do not need to make an equation. What we need to do is we need to figure out which registers are being negated and which registers are not being negated, like input registers, I mean. So yeah, and we do not even have to solve the equation then, if we know that, because we solve the rest of the collapsing of a tree into a single variable that was only ends. So we know that the registers have to be, all of the input values after the initial step have to be 1, which is great, because now we can, yeah. So can we do it manually? We can do it manually, and it's only 64-bit values. I'm tempted to do it manually, especially that I have this printed out now, so it's super easy to do it manually. We're going to do it manually. I'm sorry. Which means I'm printing too much stuff right now. I want to only print this stuff. And furthermore, so this is the Python thingy. Well, it's not Python, right? Print py. And yeah, close your eyes. If it's less than, how much is it? Like 4, 5, 6, 7, 8, 9. If it's less than 10, then continue. Less than 12, then continue. Yeah, alright. And I should have 16 lines left. I'm going to again remove the inputs. Nice. And I'm going to double check that we actually have 16 lines. We have 16 lines. That's fine. Yeah, now I'm going to do it manually, because it's like, it should be easy, right? So, asdf.txt, and if it would be more, I might like actually do something else, but it's fine. Can we, well, whatever. This is like a riddle basically, and I'm going to copy all the inputs, and okay, Okay, so this is ASDF, and let's call the other one xyz.txt, and I'm going to input the inputs here, not here. Go away, I do not need you right now. Perfect. Let's do this, let's do this. Okay. And now we're going riddle solving. 49. Let's look for 49. 49 is here, and if it's 1, then we get a 0, so we cannot have it 1. It has to be, let's maybe do, by the way, let's maybe format it a little better. Okay, so it has to be 0. We know it's 0, we can just maybe do it like this. Next, 166. 166 has to be, it cannot be 0 because then we get 0, so it has to be 1. 19. 19 has to be 0. 189. 9 has to be, whoa, what's going on here? No, it has to be 0 as well. 205. 205. Oh, it has to be 1 because it's directly the value is used, so it has to be 1. Here we have 1 because we want this part of the equation to be used, not this part, so it has to be 1. Yeah, I guess you know the drill. Here we need 0. There are 64 of these, so yeah, you can make yourself a nice cup of tea or something like that now. It's 0 here, right? Yeah. 15, it's 0 as well. 18, it is 0. I don't expect too many 1s, I expect more 0s. Here, directly the value is used? No, we need 1 though. Wait, can we do, no, I wanted it to highlight. You know what we are going to do? We're going to do something funny, but it's going to be a little easier on us. New view into file, okay. Now remove this, no. Because it's going to be the same view, like a view into the same file, so which means we can just double click it and it still doesn't highlight? No, because we are looking for it. Yeah, I guess we have to like double click it here to highlight. Ah, that's bad, okay. Here we can go with a 1. Here we can go with a, we need to go with a 1. Yeah, this is the problem with my current approach. Here we need to go with a 0. Here we need to go with a value of itself, that is 1. Here we need to go, this is the, yeah, 1, 0, because it's negated. So it's 0 negated gives us a 1, and we need 1 everywhere. Negated, so again, 0. 202 is here, so we need it to go for 1. Is the value directly used, right? So it's 1. Negated, but 0. Negated, that's again 0. 1 because the equation is here. Perfect. Here we go with a 1 as well. Here we go with a 0 because we need to use this part of the equation. 186 is 1. Perfect. Here we get 0. Okay. Here we get again 1. 209 again 1 because we need this one. We got a 0 here. 13, that's a direct value, so it's 1. Negated value, that's a 0. Negated value again, it's a 0. Here we have this part, which is a 0. Okay, here we have a 0 again. We are close to being done, thankfully. So 1, that's a 0. I'm pretty sure, like, it looks pretty bothersome what I'm doing right now, but on a CTF it is the right way to do it as soon as you figure it out, because it is faster than writing the script which I wanted to write. So keep that in mind for CTFs, but sometimes doing manual work is better. 147 is here actually, and it's a 1. 124, it's here, and that's a 0. Yeah, we have a screen worth of more. This is direct value 1. That's a direct value again. That's 1. That is, what is it? That's a 0. 170, it's a 0. 68. It's probably, that's a 1, a lowest value. One for 5. That's a 0. Okay. 120, that is a 1. 168. It's a 1 again. 145, it's a 0. 177, it is a 1, sorry. Here I see it's negated, so it's a 0. But a 0 as well, it's up there. 79, where's 79? I do not see it. What? Why do I... That's weird. Why do I have no 79? Okay, and this is weird. Because I should have said... Is this the bug which is... That's probably the bug. Here, this 79 is probably the bug. Because it's only 1 bit, I'm going to guess that it's a 0, it might not be a 0. But yeah, this is the problematic part. This is... I'm going to mark it as X79. This is why everything else didn't work. This is the same problem with it. Yeah, okay, so that's all of them. We found the bug. Finally, we found the bug. But it might be a bug, but it doesn't have to be a bug. It might be just me not copying the last line. No. Okay, that's fine. How many do we have successfully copied? It might still give us the flag anyway. 56 lines, so I'm missing 1 byte. I do not have 1 byte worth of registers. This explains a lot. Okay, you say that I screwed up 120. Let me fix it. Thank you for being for actually watching me do this, because that's pretty annoying. You're saying that it's supposed to be a 0. It is supposed to be a 0. Thank you. You are amazing. Yeah, so thank you for bonus play, ABC, and Onur for pointing that out on the chat. Cool. Now, what I'm going to do right now is, because we probably have 7 letters already, which means I can just copy this, and I can just take a look if maybe we can already solve it. We can guess the last letter. Wait, okay, that's fine. Now what I have to do is I have to do this again and do this, okay. And now I have to copy this to Python, I guess. No, let's just copy it to a random internet page. It might be that it's 7-bit ASCII though. Binary to text. Yeah. Okay, convert. Yeah, it's reversed. So, is there an easy way for me to reverse it? You know what, I'm just going to do something else probably. I'm going to do like, oh, okay, let's reverse it. Before I start doing weird stuff, let's just reverse it. The flag will be reversed. No, this isn't an ASCII character. But still might be fine, because I might have the order wrong. Now, the question is, where did I get the order from? I did get the order from the inputs, right? So the inputs are... But wait, before I even go there, I'm going to check it for 1 character. So we have this... I'm going to split it by 8. And ASCII has this funny thing for it, that the top bit always has to be 0. So the question is like, why this is 1? Because did I make a mistake? Again. Yeah, it's supposed to be 0. Okay, so now I found the mistake. So it's supposed to be 0. We can try it again then. Maybe that's fine. Wait, what? Something. Oh, right, because I have it. Never mind. Okay. Okay, now we can again reverse it, put it in that website, and then we'll have to reverse the flag again, by the way. Okay. Wait, copy it. Okay, 1, 2, 3, 4, 5, 6, 7. So, well, this looks like a flag, I would say, because we have this Q3K here. We are missing one character though. So 2, and I cannot guess what the character is. 1, 2, 3, 4. Yeah, you are missing one character. Maybe the character is just like a zeros. How do I know it was reversed? It was I know that it was reversed because of yeah, as I said, like the top ASCII character. Well, okay, that's even not true. I didn't even look at it. In binary, when you send bits, right, you can set either the most significant bit first, like if you want to send 01, 01, 01, 01, right? You can send this bit first, then this bit, this, and so on. Or you can send it the other way around, like this bit first, this bit then, and so on. There are 2 ways to do it, either from the front or from the back. And so it's either straightforward or you need to reverse it. But that's just it. Like, it's one of the things you learn, that if it doesn't work for binary, reverse it and try then. Same for hexadecimal, same from other stuff. It's super context specific, of course. It's really context specific, but yeah, if you're trying to transmit a binary, you should try like the reversing stuff, like I just did, just reversing the string. Okay, so where are my missing registers? Let's go here. My missing input. It's a wire, and the wire is here. And it's being clocked. Did I make some kind of a mistake last time? Because it shouldn't be clocked. And it is clocked, as you can see. Well, for one thing that it's clocked, the second thing that it's being assigned to, why is it being assigned to? Yeah, I'm pretty sure I have a mistake with these last 8 registers. Why last 8? I'm not really sure, because what we did last time, one of the things we did last time is we removed all the conditions of assigning to these like registers the UART values, like the values, the bits which are transmitted through UART, through the serial bits, they were put into registers, and we removed all of that code. I guess I can show you that, because that is somewhat important to take a look at it. Yeah, this is these 2 files. So leave it like this. Now, if we go somewhere here, yeah, as you can see, we basically removed all the lines which had this N4, because we figured that N4 is some kind of a latch or like a register or whatever, which says a flag, which basically says yeah, take the value which you have received last time and put it in one of the registers. And this is like 154. We put this 154 later as an input. It's one of our inputs. 154. Yeah, it's one of our inputs, as you can see. So we basically, it was originally a register which got assigned the value that we sent through UART, and we removed that register and instead we set an input to it. So that's fine. Now the question is, what is wrong with like 81, for example? Can we find the 81 here? I'm going to... Okay, so now I'm looking in the file where we do not have removed this N4 stuff. Yeah, this is a register, we didn't remove it yet. And it's being assigned here, and that's it. But I'm pretty sure we actually removed 64 lines with N4. Which means our script, which was enumerating the registers, failed. But that is it fine, I guess? Yeah, I'm wondering if we can do it in a... no, I don't believe we can. So let's go back to the code which we had last time. This is the test bench. And the test bench, what it was doing, it was basically scanning everything for the... So wait, what about the... Oh, one thing, by the way, I can do. One thing I can do is I can look at these N4 lines which contain N4 and look which registers are not my input registers. Well, I guess I can even take a look here. Like, here, which of these registers, because there should be like 64 of these registers, or like inputs, which ones I did not use. And then I will have 8 missing ones, which I can put here. Easy. Now here's the problem. I have no idea about the order of these registers. And there is like, what? 8 factorial of 8 possible values where I have... But factorial of 8 is a small value. It's a small number. We could just brute force through it. The problem is that we have no idea how to distinguish it, and half of these values, or more than half of these values, will be printable anyway. So we cannot brute force it because we do not have a way to figure out what character is the correct character. It might be slightly simpler than that, depending on how many bits we have set and how many bits we don't have set. For example, if we have only 2 bits set, it might be pretty obvious, but it's one of 5 values, for example. But in the end, we would have to brute force the flag submitting thing on the website, and you do not want to do that because that gets you banned. So no, we do have to do it the proper way. And before we get to the proper way, I would like to... let's run this test bench again and let's see what happens. So do we have... How do we run it? I think we had a make script. Yeah. And now we can run it. Yeah, okay. And this is where it starts displaying the weird registers, these registers, where it fails at the last byte. The last byte might indeed be more problematic than other bytes for some reasons. But... So, I'm wondering why would that be? If I remember correctly, we are doing the probe around this line. So 55. Yeah, this is still fine and this isn't fine. Are we doing the probe too late or too early? Maybe we are doing the probe too early for the last byte. where are we doing the probe? We are doing the probe at this line 8311. 8311. Where is 8311? Okay, 8311 is yeah, it's here, around here. So this is like already everything was sent, but maybe the last byte was not processed yet. That might be the problem. So what I'm going to try to do is instead I'm going to try to print the registers at this point, which is or yeah, that's fine. That's 8358. So a little later, when we wait a couple of more clock cycles after sending the last byte to see if it works. And now we still get the same registers. Are we sending the last bit correctly? We have 8 bytes. 1, 2, 3, yeah, 8. And we send the start bit. For 8 bytes, we send it. And we send the stop bit. But that would, if we would fail with some not sending the last byte or something, we would fail at the last bit, not the last byte. And we're failing at the last byte. Oh, you're suggesting, bonus play is actually suggesting something else, which I didn't understand at the beginning. He's not suggesting to brute force this 1 byte here, he's suggesting to brute force the thing in the relator, which is a great idea. Bonus play, that's a really good idea, we can do that easily, let's do that. Yeah, I misunderstood the idea. So what we are going to do is we are not going to... I'm going to make a copy of this file. I'm making a copy of this file. The copy is made so I can play with it. Okay. And now, which is our challenge? Is this our challenge? No, this is our challenge. Okay. Okay, so pin 37. We want to take the, at the end, we want to take the state of pin 37 and pin 11. So here, okay, so sim, I'm going to change the sim to take an I, where I is going to be the character. I know it's a printable character, okay? So I'm just going to go for printable characters. 7E, I don't remember what's 7E, I think it's a tilde, like this character, but whatever. I++. And I'm going to run the sim for all of it. Now what the sim is going to do is, the sim is going to, in this password, it's going to put the flag which we have, which I already lost. Where's the flag? Give me back my flag. Oh, here it is. Yeah. So we're going to put this there, but in the reverse order. 2, Q, 3, K. Okay, let's put this. And now, in the... You know what, I'm going to actually... I have a weird feeling. I'm going to start with 0 here. Okay, and now password of 7 is going to be equal to the bit index. It's not really a bit index, we don't care, we are not going to change it. We are going to remove this though. And what we are going to do is we are going to do like this. Print, no, write password 8 characters to standard output. And then at the end of the day, we are going to send everything, blah, blah, blah. And at the end of the day, what we are going to do is we are going to printf a space and then two values. Where the first value is the value of pin 37, and then the pin, sorry, what was pin, what was it? 11? Yeah, 11. Pin 11. Okay. Cool. Now we can run. Okay, did it flip at any point? Yeah, what I'm looking is basically like one line which has 1, 0. It did not flip at any point. That is not a good sign. Maybe I'm not running it enough times. Like, sorry, not enough clock cycles. Total clock cycles. How many clock cycles do I have? 9. Let's do it like 10. Like 20,000. I mean, I don't care. Okay, here, what happened here? Oh, I know what happened here. It's a new line. Okay, so now another idea is I'm actually going to put the first character at the first here, because why not? No, nothing. It's an excellent question. What is going on? Okay, I am going to increase the space of search into the full range of possible characters, which is 255. And I am going to change it back because I'm pretty sure this is the beginning of the flag and this is the end. And if it doesn't work, I'm going to take a look at the solution, because this is pretty weird. What do you mean I didn't recompile? I'm running make. I do recompile each time. I'm pretty sure of that, actually. Or didn't I? Yeah, I didn't. I'm sorry. You're right, I didn't recompile, but before that I'm pretty sure I did. So let's do that again. But before I do that again, I'm going to take a look. No funny business going on here with non-ASCII character. No, everything is fine. Okay, that's good. Now you know what, I'm going to do like this. Make, okay, this is make sure that I will recompile it all the time. Wait, whoa, we had a flip. I saw a flip here. Yeah, here we have a flip. Okay, so it was at the beginning. It wasn't the last byte, it was the first byte, actually. 42Q Freaky, 42 KrzaQ, exclamation mark, and a smiley. Okay, that's the flag, so we got it in the end. Thank you for the people in the chat for actually throwing out ideas how to fix it, and the mistakes I'm making, because this would cost us some time. So let's see, bonus play noticed, so that I didn't recompile, ABC noticed, and Scumpinatos didn't notice. I'm sorry if I totally mispronounced your name. Yeah, so that's it. I didn't make when I changed the probing index. But given that this is the first... Okay, let's do it like this. If I didn't really make the make when I did change the probing index, let's try this again in that case. I'm going to do this. No. I'm going to do this. And I'm going to see if that would fix anything. Because if it would, then we can still solve it the other way. Yeah, I mean, I don't have to really do it. Okay. 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 And okay. It's, now I'm running make. And I'm even printing some other stuff which I should not be printing. Look at that. Okay, here I had 9,000 cycles, that might not be important, but let's just do it. Okay, yeah, that's perfect. As you can see, I'm getting 2 bits, which is somewhat a thing which I was afraid of. And I always selected the first bit for some reason, and well, not really the first one. I always selected the wrong one for some reason. So, for example, if I have 81, that's this one, I should have selected N173. Now let's look in the file without removed. Which file was it? Okay, so this is the file where I did not remove N4s yet. What I'm going to see if N4, the condition with N4 is next to this input. Yeah, it is, obviously. Okay, that means we can solve it now. The other way. So I'm going to show you the equation way again, or attempt to do it the equation way. And I did have a script which I did have a bit mapping script. So yeah, I need to change it here to set all the correct bits for these ones from this one, because these are not correct. I need to fix them. The last bit, I know it's 137, that's perfect. Oh, actually I could have left them, because I know that these are the incorrect ones, so... Well, I'm not really sure all of them are incorrect, I'm kinda sure all of them are incorrect. And... okay, I'm just going to look for it. Yeah, this is also fine. Wait. Oh. It's already here, so that isn't helping me a lot. I'm still not getting the correct ones, I think. Because yeah, 188 actually has N4, but it's already somewhere else used here as well. So I'm still not getting the correct bits. That's pretty weird. Let me do a grep by... What I want to grep for right now is this, and for thingy. Okay, and in no uart-b. I'm wondering if we can somehow deduct from this, like for example register numbers, what is the proper order of registers. So let's look at the beginning, because we know we have like this, for example, correct, right? So N49, where are you? It's here. No, it's not the first one in any way. So we cannot really deduct it. And the problem is that these are probably like counters. And it would be like a really convoluted network to actually determine the order of this one. So we still cannot, we can easily determine the input, but we cannot still determine the order of it. So you know what? We have still a couple of more minutes. I'm just going to pretend that like I didn't make whatever mistake I did make in my script, in my test bench, and I'm going to grab the results of my previous attempt when I was doing it previously when testing the challenge. And we're going to still try to, well, I'm not really try to, I'm going to show you how it would work the other way around. Like if we could actually have the proper Verilog and generate an SMT file, how would it look? What would you have to do? So I'm going to copy it from the other, my other attempt, and it's going to take only a couple of minutes. I just want to show you how, if it would work and I wouldn't do a stupid bug, which I don't know where I did. Well, I know where I did. I would have to basically debug which bit is set for the last byte. This is what you have to debug. Or for the first byte. That might be the other thing. Well, whatever, doesn't matter. It's debuggable, like I could still debug it and on a CTF and be able to figure out the order of registers. I don't want to waste another stream for that, and we have 10 minutes. That's why I want to show you how, if it would work, then what we would have to do. So what we would properly get is something like this. Like this is the wires which you saw, but we have like the correct pins this time. This is the same notation, but it's a little shorter. And all the N4s here are actually just commented out. So having something like this, what we attempted to do last time, right? We attempted to generate using Yosys to generate the SMT equation. And I'm going to change the file name because I am going to use the proper one, like the one from the, when I solved it the first time. And it solved me V, and I'm going to generate, this isn't really required. Okay, I'm just going to generate the SMT thingy. And I'm going to show you which part we were missing. Okay. So it generates the solution. And this is the part which we had. Now, if we scroll down, this is the part which we are missing. The part where like this like ETA something is visible, the part where like this not or and other stuff is visible. We didn't have this part. Like our file was basically truncated here due to that 1 byte missing, right? The byte which we don't know which pins are, which registers are those. Oh, now I might know why it did work while I was testing and not on the live stream, because while I was testing the challenge, it had a different flag in it. So maybe KrzaQ modified the challenge a little bit, and my approach requires some tweaking. That might be it. Okay, whatever. Now what we want to do is basically we want to, solve this pin 47, because this is the pin which is responsible for the green LED, and we want it to be low, to go low, right? Like 0, false. And what you basically do is, do I have it opened? Okay. I do have the website opened here. You want to go to this website and read this tutorial. I can give you a link, but yeah. Here we go, just a link. Okay, and what this tutorial says basically is that you have to write an additional assert. You remember when I was showing like how to use Z3 and I created a solver, and then I did add and I added the condition which I want to met? We have to do the same thing. We are also going to use Z3 here, but we are instead of using Python, we are going to use the SMT2 notation, which is a little different. So it's basically like this. We have to assert. This is like adding what we want, and it's like a Lisp-like format. What we want is for solve me n, which is like kind of this, like the object of the device pin 37. from S1. What is S1 I will write in a second. That's basically a function of like a variable of the state of the machine. That's how I understand it. I do not understand fully the SMT notation. I do prefer the Python notation, in all honesty. And we want it to be equal low, which is false. So here we go. And then we want to check sat, which is like, remember I did like solver check in Python. This is the same thing. And then we want to do get model. In Python I did s model, and it's the same thing. Now this S1 here is again the state, and the state you do something like this, and this is described, everything is described in that tutorial. Declare fun S1 and solve me state. This is the state of it. At least that's how I understand. And that's it. Now what we do is we run this in Z3. So Z3 solve me SMT2, and it gives us for each variable, it gives us either a true or a false. It gives us either a 1 or a 0, right? And what you have to do right now is you have to think like, this solve me 43, which pin is it? And it's, you would have to write some Python script for it. So here, like reading this, we have no idea what pin it was. The way you do it is basically you can, because it doesn't directly tell you which pin is which, but I think it goes in the order of declarations from the file. So you can quite easily translate this into the name of the input, which I've already hidden again. Here we go. So yeah, for example, input CLK is the first one, so CLK is solve me 0. Then we have N10 and, well, it's actually a different order, but that doesn't matter. There's always a comment, it seems, so it's actually even easier than I thought. You don't have to speculate at all. You just like read the comment and then grab this. And this gives you a mapping of, between what you have here, like 43, for example. Let's look for 43 again, now that I did actually notice this. Yeah, so 43 is N5. And in solve me is the solve me. You can look for N5-ish. Yeah, N5 is one of the inputs, and you know that this is like, I don't know, bit like 47 or whatever. So you put like 1 in bit 47, and in the end, you like backtrack, and in the end you get the order of bits, and having the order of bits you get the flag. And that's it, because this model order is not totally in a different order. It's totally random. You cannot rely on the order of a model. It's pretty weird. So that's the original solution which I wanted to do last time, but I failed due to, well, not noticing that the challenge changed, and my approach to solve it needs some more tweaking, because I'm pretty sure that my method still would work. So that's it for today, actually. Yeah, we did get the flag in the end, even if it was with a different method than I intended to use, which I'm still happy that we did get the flag. What we can do is we can take a look at the, you can look at the presentation, by the way, with the solution. So this is it. Is the flag here somewhere? This is, by the way, a screenshot from my other tool, the one which I originally used, and I had like the red LED in the red color and so on. And I marked actually all the counters at blue. The presentation was done by KrzaQ, I believe. Yeah, he has some like more, read it, because he used another method to solve it. I think he used 2 different methods for it. And like he actually knows what he's doing, and so, because I still like struggle with Verilog. So yeah. Now he doesn't show the flag, or does he? Yeah, yeah. So yeah, we got the right flag. 42 Q3K. That's cool. Perfect. So that would be about it for today. I am going to take a look at the questions, so if you are interested in me answering a question, you can still stay a while. Next week I have no idea what we will be doing. I have some ideas. Oh no, I know. We'll be doing another challenge from Google CTF. I think we're going to do Dev Master if I remember correctly. But yeah, that's next week. Cool. Any tips for reverse engineering a Rust binary? No, not really. I think I've done it once or twice, but that's about it. I don't have any tips yet. I guess like one learns about tips after doing it 20 times ish, so like an arbitrary number, but I do not have any tips. I've again done it once and just like wasn't different than ever reversing too much. What do you think about concurrency support of C++ versus Go? I do not know Go enough to fully appreciate the current concurrency model. That's my answer. C++ is good concurrency support, I would say, but I do not know Go enough to speak on it. Yeah, this is about the mistake which I've made, which, yeah, well done for KrzaQ for spotting it. This is, yeah, what I mentioned already. I did thank you, I believe, and bonus play also. We also chatted about me not recompiling it, even though I thought I was recompiling it as well. So that's it for today. Thank you for being here. And yeah, is the Game Dev Challenge coming late July, still July? No, it's beginning of August. Like as soon as Paged Out is out, I'm going to announce the summer Game Dev Challenge, basically. Oh, I might actually advertise the Game Dev Challenge in Paged Out. No, that doesn't make sense. It just runs for 2 months. Whatever. So yeah, I still don't know what the topic will be. We'll see. Thank you for being here, like, yeah, suffering here with me today. And see you, I guess, next week. Tomorrow the Polish live stream is off because it's a Swiss holiday. I might not be home, basically. So that's it. Thank you. I wish you a great evening, happy programming, happy hacking, and see you next time, next week. Thank you to my moderator, KrzaQ, who was helping me a lot today. Bye-bye.